So welcome back to Golden Time. We are working on two-way relative frequency. And this is amazing because you can use absolute numbers to determine frequency and vice versa. Using relative frequency to determine absolute frequency takes a little bit of doing, but it's totally worth it. Our first problem, I'm looking at it on Khan Academy, and I'm looking at it on the phone, so I'm going to have to write it down here. We have 200 students over here, and this has been converted into a two-way frequency table for the following dimensions. We have males, females, positive opinion, and negative opinion, and neutral opinion. We have absolute numbers over here, 40, 42, and then we have a total row of 82, 36, 56, 92, 14, 12, 26, and then we have our total row right, oops, I don't think I need it over there, T, total row, 90, 110, and 200. So I need to find out the relative frequencies for all of these. Okay, so if we're converting this to regular frequencies, this is simply 40. So to do the column frequencies, oh no, these are all column frequencies, huh? So 40 divided by 42, or 40 divided by 82 is 1.8%. How many decimal points does it need in our questions? Nearest percent. Okay. So this is going to be 2% then. So, oh wait, what? Hold on, I didn't do the math right. 40 divided by 82 equals, wow, how did the math go so wrong? I didn't even check it. 49%. 49%, and that gives us 51% over here. I'm going to do that for the rest of the table. This is pretty simple. 36, oops, I didn't check my number. 36 divided by 92 was 39%. And 61. 14 divided by 26. 54%. And this becomes 46%. Uh, 90 divided by 200 equals 45%. I should do some of it without calculator, but whatever. Okay, so the first question, I just had to give the relative frequencies for everything, and that is super easy. 49%, 51%. These are all column frequencies, and I don't have to worry about it so much. The problem will come when we have to Oh, whoops. What percent of males had a negative opinion of housing? 39%. What percentage of females had a negative? Oh, 61. Based on the relative frequencies, what can we determine? Association between gender and opinion. No, females are pretty equal on, relatively equal on this. No, actually, females are relatively higher. What's going on over here? Trends in categorical. I have to try this one again. Oh, okay. Trends in categorical data. Fill in the missing values. Okay, so we have P, F, O, M, and we have some absolutes, and we're going to try to determine the missing values. 30, 44 total. 74, then we have 46 and 90. So how can we abstract the rest? What were we doing again? Oh, and we have the relative. Oh, this is the one I was looking for. Okay, so we have to create this along with our frequency table. So let's make this with P. This is going to be in O, M. All right, so we have R. Whoops. Back. We have R percent, C percent, T percent. 40.54, 42.86, 18.75. Wow, these are really weird numbers. 59.46, 48.89. This is the information they give to us. 27.5. So we have the total is, and then this one is 46.25 of the total. Alright, so we're going to make one for F, R percent, C percent, and T percent. 46.51, 57.14, and 25%. 53.49. Oh, that's ugly. 9. 51.11. X. 53.75. And our column total 50%. 43.75, 56.25. Alright, so our relative frequencies. The rows always add up to 100, but this is something we should know and you can use to abstract the remaining thing. So this plus this equals this, or equals. Let's do this with 18.75.27.5. So 18.75 plus 27.5 equals, whoops, let's clear this, 18.75 plus 27.5, 46.25, okay? So with this, we had to subtract, which means this is 28.75, 28.75 plus x equals, so that's a relative frequency that we're missing pretty easily. So 18, so this one for the column total, right? Column total, column total, column total. C plus C equals C. Okay, so we're going to use this. Oh, x equals 28. Okay, now to find out all of the missing values. So what we know here is that $30 is okay, so let's confirm some of our math so that we're going to follow our algebra real nice. 30 plus 44 equals 74. So the row percentages relate to that. Then 30 in relation to its column is this one, 42.86. So 30 over 4.4286 equals column total. 30, let's clear this out, 30 divided by point, what was that again? 4286 equals 70%, equals 70. And then if 70 is over here, we're missing 40 over here. And then if 40 plus 46 equals 86, and that makes this into 160 and 160. All the math works out. A little bit of algebra brings you a long way. We could have used any of the numbers to find out the missing numbers, such as, what else could we have used? If we were going to use 46 to abstract the row, let's row. Okay, so 46 in relation to its row was 53.49. Gives us the row total. (46) divided by 0.5349 equals 86. Boom. That's pretty nice, right? Algebra brings us answers. Yeah. I don't know how I would use it to find the other missing item, but I know that you can always abstract the total when you have the relative percentage. So I'm going to fill that out over here on my Khan Academy. This is 40. This is 70. This is 86. And this is 160. Checking it. I got it all correct. Oh, thank goodness. All right. Relative frequency table. Support for candidate X. 75 supported X. How many in the survey were Californians? All right. So we have a relative frequency table. In this we have two categories. Sub X N X. In this, so the two locations are Virginia and California. And I need some more space for this, I think. Let me write this first. Whoops. Too close. Whoops. All right. R percent, C percent, T percent. 37.5, 30, 15. These are all very clean numbers. 62.5, 50, 25. And the row total becomes 40. Whoops. That's ugly. 40. 40. And NX R percent, C percent, T percent. 58.3, 70, 35, 41.7, 50, 25. This is 60 over here. Then we have our column total. C percent, T percent. And this is a 50. It's 50-50, huh? All right. So the number we know for making our square, we have X, N, X, V, and C. We know that supports is totaled of 75, so let's abstract the rest. 75. Right, so we get 62.5, 62.5, oh whoops, so 75 times, not divided, times 0.625 equals 47. 47. times 0.28. Are you?
I'm done with the chapter.
Okay.
So I'm just trying to get in the blanket.
Don't mess up the plug, please.
I won't.
Okay. Now I need to abstract the rest. Do I have any more? Oh, wait a minute. I abstracted the wrong numbers. 75 randomly selected Virginians. Virginians. Oh, that changes the whole thing. Wow, this thing's really smart. Okay. So Virginia has a total of 70. What? Hold on. 75 support X. 75. Okay. So this is like what we have over here. So we have 75 divided by 0.375 equals the column total. 75 divided by 0.375 equals, okay, let's try that again, let's make sure. 75 divided by 0.375 equals 200. So 200, 75 plus 125 makes 200. Alright, so now I need to find out my column frequency. So we have, okay, equals, oh, hold on, RT, row total. 75 divided by 0.3 equals column total. So 75 is 30% of the column total. 75 divided by 0.3. 250. Very clean numbers. 250. 250 minus 75 equals 175. Okay. I can do the same thing for 125. 125 is 30%. No, 125 is 50% of the column. Well, that's pretty easy. So 125. And that makes this 250. And I can't add 300. All right. So I have all of the math. How many people in the survey were Californians? This was 250. Does the table show evidence between... Okay, so association. Cali support X. Let's have a C. Californians were 50-50 on the on X, even though relative to Virginians, the volume was more. So less Virginians supported but it's hard to say. So Collins percentages were equal. 50%. Oh wait, I need the relative frequency. So 40%. Okay, maybe I need to see what applies over here. So is everything nullified because column percentages are equal? Maybe. I'm going to put so equality, that's my first thought. Maybe. I'll put one dot on it. 50% of Californians support X, but 40% of all people support him. Okay, so we're higher than average, that's true. No, because 50% and no, maybe may also be true. Evidence of association. %% of the study, yep, that's true. And maybe this is also true because it's 50-50. So the relative frequency, it seems like a lot applies here. And I feel nervous about clicking everything because it seems like it has applicable. Candidates who support candidate X have the highest joint relative frequency. Okay, I'm going to take out the column percentage equality. And I'm going to put it all on yes. Check? Nope. Get help. Okay. So let's read the hints. How do they explain it over here? Okay. 15% of all people in the survey are Virginians who support candidate X. There are 75 of them, okay. Okay, so according to the help text over here, 50% of Californians support candidate X, but only 40% of all the studies support him, so it has association. And then they said that 62.5% are from California, but 50% are from California. Wait, hold on. Gotta pause the video.
Play games. Play games. I did like 3 hours and 20 minutes of reading today. Dad.
Yeah?
I read from like 11 to Alright, keep that in column 46 to now played besides the party?
That's it. Let her know we're coming tomorrow morning.
I'm just like, there's no other like events.
Yeah, we relaxed a lot today, baby.
Yeah.
You were a relax.
Okay, make sure you stay snug on Monday. It's gonna be for cats and dogs. Yes, you better get a leash for an umbrella.
92%.
Okay. Love you, my mom.
8%. $168 divided by 220 equals 76%. 76%. 24%. Okay, so if we're gonna do our relative frequency, filling all the missing values. I forgot how to do this a little bit. Okay. What am I doing here? Oh, right. Okay, so if the relative frequency for the columns if the total is 72, and this is 92% chance of being in a lose, then the number is 72 times 0.92, right? $66. We have 66, and we have 4, 6. So if we do 6 divided by 72 equals 8%. Perfect. And you just do that with the other numbers, right? So 92%, 0.92 times 168. 168 times 0.92. 155. 155. So if the remaining 8 divided by 168 equals 5%. What? That's not right. 168 times 0.92. Okay. 155. And then 168 minus 155. My math. Let's see if this is right. I'm going to fill this in for the missing volumes based on frequency. 13, 66, 6. Check. Damn it. I should check this. So no association. Oh, okay, no association between no association between what two between winning and harsh. So between these two axes, what am I doing here? So normal and harsh conditions, I don't need to, I can just do it evenly along the axis of winning or losing, right? Okay, so we have to refigure out this. What did I calculate wrong? If winning and losing is independent of these variables, then I don't need to use this one to calculate it, right? Because just because there's a 92% on this side doesn't mean that I need to calculate it like that. Let's try calculating it with the win-loss ratios. And let's see if I get it right this time. So I'm going to leave it up. Let's go ahead and make this again. Okay, so we have wins, losses, normal conditions, and harsh conditions. We have a square. We have 168, 72, 220, 20. This is 76%. This is 24%. Okay. What am I going to abstract here? So I know. What do I know? How did I do this before? Oh, I didn't explain it before, did I? Alright, let's see if I can figure this out. Reason this out. So, winning and harsh conditions. No association. So that means normal or harsh is going to be similar distribution of wins and losses. So if I just do along with the rows, and I just do what is it? 20 times 0.6. Okay, let's try out this funky math. All right, so 20 times 0.76 equals, let's see, 15. And 5. 220 times 0.76 equals 167. 220 minus 167 equals 53. Alright, let's try out these numbers. Make this 15, make this a 5. Check again. Nope, get help. Alright. Layton won 168 out of 240 games. Oh man, come on, really? So there's a... Okay. $168 over 240 equals 70% chance to win. So then he'll win 70% of each game. This is the one that I missed. So since there's no association over here, I just do just calculate the win ratio, not just the win ratio. Actually it is the win ratio. I missed this part. The obvious. Wow. Okay. Gee golly. What does it look like with this? N, H, W, L. Let's pretend like I know what I'm doing for the first place. 168, 72, 220, 20, 240. So win ratio equals 168 over 240 equals 0.7. Weather ratio equals 220 over 240. Wow, that's ugly writing, but whatever. 220 divided by 240. I just did that up above, but that's 92%. But because weather is irrelevant, we go with this one. So winning will be equal on both sides. So 70% of, so 0.7 times 220 equals 154. And the remaining is 6 plus 8 is 14. I just have to fill in the blanks over here. So 6, and then 220 minus 54. Oops. 220 minus 154. 66. Alright, so let's try this again. And this is why I do the videos, because there's a lot to learn and I don't want to give up before I learn it. Check again. Finally! Yes, last one. I'll practice this again tomorrow or when I have some more brain power. Alright, last problem of the night. Let's try to redeem ourselves. John and Lauren are looking for a good neighborhood who have kids with rollerbladers. Okay. So far, rollerbladers. And there's 3 kids live in the neighborhood. David, Anna, and Miles. Jeez. No kids. No rollerblading. Nothing. Null. Okay. So we have... Oh, we need to abstract relative percentages. Let's see. Okay, so over here we have R. We have NR. Okay. And NK. 41, 3, 9, 9, 50, 12, 62, 44, 18. So 49, so 62 is the total, right? 62. 49 divided by 62, 49 divided by 62. 79%. 79%. 21%. 50 divided by 62. 80. Wait a minute. 100%, really? Oh, maybe I'll do this tomorrow. I don't really feel like powering through this tonight. Okay, no, stop whining. Shucks. 80. 80.65. Ugh. 81% and 19%. Okay. So if we're basing it on one or the other, so no kids. Relative percentages. 41 divided by 50. 82. Oh, I really don't want to do this. Alright. this for tomorrow. Putting in a bookmark. Signing off for now. See you guys later.